Okay, till now in a projectile motion, we have discussed a simple projectile motion. Like this, we were having a flat surface and projectile was moving like this at angle theta from the, this was the case number 1 that we have already discussed in previous lecture. Now, today we are going to discuss the case number 2. Case number 2, here our projection is going from the tower. Here our projection will be from the tower. The two cases that we are going to discuss, the first case will be like this for the tower, and the second when we are going to throw like this from the tower. Case number 1 and case number 2. These two cases we are going to discuss today. Okay, let's start with a case 2. Okay, the first that we are going to discuss, projection from a tower. Let us assume we are having a flat surface like this. We are having a flat surface and we are having one tower in the surface like this. We are having one tower. Now the projection is like this from the tower. We have thrown a projectile at angle theta from the horizontal axis. At an angle theta from the horizontal axis. Now, how to draw the x-axis and y-axis in this case? Okay, you are going to consider this surface, the main surface, as an x-axis, and you are going to consider this as a y-axis. This is important point in this case. These two are considered to be axes, x-axis and y-axis. Okay, what is the range in this case? This is a range, how far the object or the projectile have traveled in x-axis. The displacement in x-axis is known as a range of the projectile. Okay, and assume the height of the tower is given as h. Here h is a height of the given tower from where you have thrown the projectile. This much things are given. Now see, what is the trajectory equation of the projectile motion that we have discussed now? Trajectory equation of the projectile motion is given as y x tan theta multiplied by 1 minus x upon r. Okay, what is the r over here? R is a range, R is a range, which is equal to how much? Which is equal to u square sine 2 theta divided by g. If I am going to put the value of r in this formula, what I will get? I will get y is equal to x tan theta 1 minus x upon r. What is r? R is going to be u square sine 2 theta divided by g. So I can write y is going to be x tan theta, I'm just opening the bracket, minus x square tan theta divided by u square, I'm g taking in a numerator. And what is the sine theta? Sine 2 theta, can I write this as a 2 sine theta into cos theta. 2 sine theta into cos theta. Now so I can write y as x tan theta minus x square g. And what is the tan theta? Tan theta, can I write as sine theta upon cos theta? Sine theta upon cos theta divided by u square 2 sine theta multiplied by cos theta. Sine theta and sine theta is going to be cancelled. So we will get y is equal to x tan theta minus x square g divided by 2 u square cos square theta. This is a trajectory equation. This is a trajectory. Just I have put the value of r in the previous trajectory equation. The range. This trajectory equation is also applicable for the projection from the tower. This is also applicable for the projection from the tower. Okay, This was just to discuss the trajectory equation. Okay, to understand how to calculate the values of the given parameters from the projection from the tower, we will take one example, and with the help of example we will try to calculate the value of the range and flight time. Okay, consider one question. Write down one question. The question is given as a projectile is launched with a speed of u at an angle theta, with the horizontal as shown in a figure. Find the time of flight and range of the projectile. Let's see how to solve this type of question when the projection is from the tower at angle of theta. Okay, first complete the diagram. If the initial velocity is u, what will be the velocity in this direction, in x-axis direction, in a horizontal direction? This is going to be u cos theta. Okay, if this is the initial velocity in x-axis, what is going to be the velocity in y-axis? It's going to be u sin theta. U sin theta, no? Okay, and what is the range? This is the range of our projectile. As I told, always draw the x-axis like this. This is my x-axis, and this is a y-axis. This is a y-axis. Okay, before solving the numerical, just try to answer u of x and u of y. What is the initial velocity in a horizontal direction? It is u cos theta. And what is the horizontal velocity in the y direction? In the vertical direction, it is a u sin of theta. Okay, what is the acceleration in horizontal? We know it's going to be 0. And what is the acceleration in y, in a vertical direction? This is going to be minus of g now, because we know the gravitational acceleration works downward. Okay, as per our sign convention, we are taking this as a positive and this as a minus. That's why I'm writing minus of g. Okay, let us consider t is a time. Capital T is a time to reach, this is some point A, from initial launch, or initial point. Or you can say T is a time of flight for the projectile. T is a time of flight for the projectile. And how to calculate a flight time? We know now. We are going to use a second equation of the vertical motion. First write straight line motion equation. Now second equation of straight line motion. Plus half at square. Then put the values. And we are discussing a vertical. This is going to be y, this is going to be the y, and this is going to be y. It means s of y will be equal to u of y t minus 1 upon 2 g. Now acceleration in a vertical direction is minus g. That's why I put it a value minus of g t square. This is the second equation for the vertical motion. Okay, now put the values. What is s of y over here? When we have thrown a projectile, when the projectile is moving, what is the displacement in y-axis? Let's see how to calculate. This is my tower. Initially the ball was at this point, or the stone or projectile was at this point. We have thrown a projectile like this now. This height is h, and this I am considering r. Okay, what is the coordinate of this point? X is 0, y is h. And here, what is the coordinate for the x and y? X is r and y is 0. How much change is there in y-axis? From h to 0, no? From h to 0, it means ball have traveled h distance downward. Projectile have traveled h distance downward. It means what sy I will take? Sy will be minus of h. Because, as I told, we are going to take upward as a positive direction and negative in the downward side. For upward we will take positive, and for the downward we are going to take negative. That's why s of y is going to be minus of h. Okay, s of y is minus of h. What is u of y? U of y is how much? U sine theta. T is the time to reach a ball to that point, minus half g t square. From here we can calculate the value of t. T square g half. I'm taking this side, minus u sine theta minus t minus of h is equal to 0. Now I'm going to multiply 2 in a whole equation and divide by the, just multiply with 2 only, okay? gt square minus of 2u sine theta into t minus of 2 of h is equal to 0. Okay, now compare this equation with ax square plus bx plus c is equal to 0. Here a, this is a now. What is a b? B is minus of 2u sine theta. And what is c? C is minus of 2h. Okay, how to find the root of this equation? The value of x will be given by minus of b plus minus under root of b square minus of 4ac divided by 2a. This is a way to solve the quadratic equation. Now, the same I am going to use to find the value of t. Here I can write variable is t. T will be written as this minus of b. Now, minus of b. Minus of 2u sine theta is a b. For me, it means I will write 2u sine theta plus minus under root of b square minus of 4ac. B square means 4 u square sine square theta minus 4 ac. 4 multiplied by a is g. What is a c? For me, c is a 2h divided by 2a. A is g. Okay, so I can write like t is equal to 2u. Just I am dividing 2. I can write u sine theta divided by g. Plus minus I am going to take 2g inside the bracket. So I can write like u square sine square theta plus g and g going to cancel, 2gh divided by g square. This is a value of t. Here you know it's not needed to learn the formula. Just we are discussing these things to understand the concept, how we are calculating the things, how we are calculating the formulas. Directly they will give you the values and you will able to calculate the answer directly from the given diagram. Okay, this is a way to calculate the time taken by the projectile to reach to the ground. Okay, now we will calculate the range. How to calculate the range? Let's see. In this range is very easy. Okay, range. The second question it is asking range. For the calculation of the range, I am going to use a second equation of the horizontal axis. We know what is the second equation for the straight line motion. S is going to be ut plus half of at square. Put x over here, x over here, x over here. Why? Because we are writing equation for the horizontal axis. Okay, then we know ax is 0 for the horizontal. This means s of x is going to be u of x into t. Okay, s of x means range. Now range will be equal to u of x. What is the u of x? U of x is u cos theta multiplied by t. What is the time taken by the ball to reach from this point to this point? What is the time taken by ball to reach from this point to this time? It is same as a flight time. It is the same as a flight time. It was a time for which the ball was in air. This value of t, capital T. From here we will get the range of the projectile in this case. We will get the range of the projectile in this case. Okay, this was the first case of the projection from the top. What you need to remember? You need to remember how to take x-axis and y-axis. Be careful about the sign convention, because if it is you are taking a distance in a downward direction, if you are taking a distance in a downward direction, it's going to be minus. Okay, and when you are discussing about the horizontal and vertical component, you need to be careful with the angle. Okay, now we will discuss the another case of the projectile from the tower. Now we will discuss the second possible case when we are projecting a projectile from the tower. Okay, let's see the question number 2. A stone is projected horizontally from a tower of height 20 meter at a speed of 10 meter per second. Find the range, time of flight and angle with vertical at which the stone hit the ground. Okay, let's see how to solve this type of question when we have thrown a projectile horizontally from the tower. Okay, let us consider, as per the question, the height of the tower is 20 meter and we have thrown a projectile horizontally, now like this. We have thrown a projectile horizontally and this is going to be my range, range. What is the initial velocity given over here? Initial velocity is given as, u is given as 10 meter per second. 10 meter per second. Okay, u is given like this. U is given like this horizontally. It means it is same as u of x. What is the u of y? Is there any vertical component present in the velocity at an initial condition? No. U of y is 0 in this case. Always remember, when we are throwing a projectile horizontally, there is only u of x, which is 10. What is the vertical component of the given velocity? Is 0. Okay, rest of the thing is going to be same. Now find the time of flight. Time of flight. Okay, to calculate the time of flight, we use the second equation of the vertical case. Now s of y will be equal to u of y t minus of half g t square. What is the s of y? How much the projectile have traveled in a y-axis? Is minus of 20, no? Okay, what is the coordinate here? 0, 20, x first y. What is the coordinates here? We will get r, 0. In y-axis we have traveled 20 to 0, now we have traveled downward, which is equal to minus 20. Downward we are taking as a negative, minus 20. What is the u of y? 0, now? Because at initial condition the vertical component of velocity is not possible. Minus half g. Suppose t is a capital T is the time taken by the projectile to reach from the point O to A. Okay, then this minus minus got cancelled. T is equal to 20 multiplied by 2 divided by 10, which is equal to how much? 4. Which is equal to 4. It means time, sorry, this is t square now. Okay, t is going to be 2. Time taken by the projectile to reach from point O to A is 2. It is a time of flight. It is a time of flight. Okay. As I told, when you are considering an axis, always consider this base as a x-axis and this as a y-axis. This is my origin. This is my origin. Okay. Now, this is my origin. Now calculate the range in this question. How to calculate a range? In order to calculate a range, we always use the second equation of the horizontal motion, which will be equal to s of x is equal to how much? U of x t plus half of a of x t square. As a of x is 0, we know in a projectile motion the horizontal acceleration is 0. S of x will be equal to u of x multiplied by t. What is the t over here in this case? T is the time of flight. So s of x, this is range. Range will be equal to u of x is 10 multiplied by, what is the time? Time is 2. Range is going to be 20 meter. 20 meter is going to be the range in this case. Okay, now look at a third part, what it is asking. angle with a vertical at which stone hit the ground. Okay, let's see. It's very important question to discuss. Okay, just I'm roughly drawing a diagram like this. Here, this is a ground given like this. We are having a tower, and from this we have thrown a projectile like this. No? Okay, this is 20 meter. Here, when the projectile is hitting the ground, let us consider the final velocity is v. Final velocity is v, and it is making theta from the x-axis. It is making theta from the x-axis. Okay, can you find this component and this component? Okay, this component is going to be how much? This is going to be v cos theta, and this is going to be v sin theta. Okay, we know now. Suppose this is any given vector A, and we want to find its component at angle of theta. It will be equal to a cos theta, and the perpendicular to it will be given by a sin theta. Similarly, I have assumed when the stone is hitting the ground, the final velocity is v, and the x-axis component is v cos theta, and y-axis component is v sin theta. This is a vx, now final velocity along the x-axis, and this is the final velocity along the y-axis. Okay, we know the v of x, which is equal to v cos theta, will be equal to how much? 10, because the horizontal velocity initially is 10, and we know for the horizontal case, as ax is 0, the velocity at each point in a projectile motion for the horizontal is same. It means v of x, which is equal to v cos theta, will be equal to 10. Now we will calculate the v of y, the vertical velocity, vertical final velocity, which will be equal to minus of gt. I am using the first equation of the vertical motion. V of y will be equal to how much? U of y is 0 in this case, na? U of y is 0 in this case. U of y is 0 minus g is 10. What is the time to reach the point B? What is the time to reach the point B from this point? This is 2, the flight time, na? Flight time 2. The flight time 2. It means we have taken 2 seconds to reach from this top of the tower to the ground. It means we are getting v of y minus of 20, which is equal to how much? Which is equal to v sin theta. Okay, now let us consider, this is equation number 1 and this is equation number 2. V of x, which is equal to v cos theta, is equal to 10, and v of y, which is equal to v sin theta, is equal to minus of 20. Okay, now I'm going to find v of y divided by v of x, which will be equal to v sin theta divided by v cos theta is equal to minus 20 divided by 10. 0, 0 got cancelled. This is only minus of 2. Here you will get tan theta is equal to minus 2. Theta is going to be tan inverse minus 2. But here we have assumed theta angle from the horizontal axis. And angle from the horizontal axis. But in a question it is asking the angle from the vertical axis. What it will be? Angle from vertical will be equal to 90 minus theta, which is equal to 90 minus tan inverse minus 2. This is your third answer. Okay, let's see. In today's lecture, we have started with a projection from the tower. We have started with a projection from the tower. From here, we have started. Then we have seen a first case when we have thrown a projectile at angle theta from the horizontal axis. Okay, then we have seen a second case where we have thrown our projectile at angle 0 from horizon. We have thrown our projectile along the horizontal axis, where we have got u of y as a 0. Then time of flight, range and angle from the vertical. Now we will discuss the cases of inclined plane. Now we are going to discuss the case number 3. The projectile in inclined plane, case number 3. Two cases we have discussed: simple projectile motion and projectile from the tower. Projectile motion from the tower. Now we are going to discuss the projection on an inclined plane. The two cases we are going to discuss in case number 3. First, when the projection is like this from the base of the incline, and the second case we are going to discuss when the projection is like this. Okay. To understand the projection from the incline, we are going to take two numericals and we will try to find the parameters. First, put ahead in case number 3, projection on an inclined plane. Okay, to understand the projection on an inclined plane, let us read this question. A stone is launched upon an inclined plane of inclination beta at angle theta with a horizontal. Find the flight time, range of stone, and theta for which the range is maximum. Okay, let's see how to solve this type of numerical. First, draw the diagram. Let us consider this is a flat surface and we are having one inclined plane like this. We are having an inclination plane like this, and it is given the angle of inclination of the plane is beta. The angle of inclination of the plane is beta. This angle is how much? This angle is beta. And it is given we are going to throw a stone at an angle theta with the horizontal. Okay, we are going to throw a stone like this. This angle is theta. This angle is theta. Angle from the horizontal axis. Let us consider the initial velocity at which we have thrown a stone is u. This is u. Okay. Now, the first step in this type of question is to find this angle. Angle of the stone from the inclined plane. This is going to be how much? This is going to be theta minus beta. Na? You can clearly see this angle is going to be theta minus of beta. Then what we used to do? We used to find the component of the u. Component of the u. You will see what is the component of u in this direction. It's going to be u cos of how much? Theta minus beta. Okay. And perpendicular to it, what it's going to be? It's going to be u sine of theta minus beta. Okay, you need to find the vertical and horizontal component. Okay, now remember how to draw the x-axis and y-axis in this case. How to draw x-axis and y-axis in this case. Okay, when you're going to solve this, consider this as a origin, this as a origin. Okay, consider this inclination plane as your x-axis. Okay, and this perpendicular, change the color, this perpendicular axis you are going to take as y-axis. Now the numerical is going to be very easy. Remember, the inclination plane, the plane you are going to take as a x-axis, and perpendicular to it you are going to take as a y-axis. Now it's very easy to solve. Let's see. What is your u of x? U of x is how much? U cos of theta minus beta. Similarly, what is your u of y? Initial velocity along the y-axis. It is u sine of theta minus beta. Okay. Now here we are going to calculate value of a of x and a of y. Let's see how to calculate a of x and a of y. Because in an inclined plane, the a of x is not going to be 0 because the gravity will have a horizontal component also in this case. Let's see how. Suppose at this point, how the gravity is going to work? Gravity will work downward, no? gravity will work downward. Okay, it will have a two component. One component along the plane like this, and one perpendicular to this. One perpendicular to this. And this angle is going to be angle of inclination, which is going to be beta. So this component will be how much? This is going to be g cos of beta. And what is the value of this component? This is going to be g sine of beta. Now everything is easy. Okay, what is a vertical component? What is a vertical component as per the x-axis and y-axis you have drawn? The vertical is minus of g cos of beta, because this is your y-axis. Now you will see this is your x-axis, this is your y-axis, and if you will see the g is like this. Now here this is a g cos of beta. This is your y-axis component, and this is your x-axis component. What is the x-axis component? It's downward. Not the x-axis showing like this, negative x. So I will take it is minus of g sine of beta. Only you need to calculate these four values. The rest of the thing is going to be very easy. Okay, here at this point I need to clear one thing, that the point G, if you will see the point G I have drawn at this plane. Actually this is not in a plane. Okay, to make thing easier, to make a understanding better, I have drawn a G like this. Actually the G, the gravitational acceleration, is going to work on a particle. Now suppose I am discussing for this point. Here the G is going to work like this, G. Okay, and this is going to be, and this is going to be vertical component. To make our calculation easier, to make you understand the topic, I have drawn a G over here. Remember this point. Okay, okay, the same, how to calculate a time? To calculate a time of flight, we use as a second equation of vertical motion. S of y will be equal to how much? U of y, or you can write like this. S is going to be ut plus half of at square, straight line motion. Put y and y. S of y. What is the S of y? What is a displacement in a y-axis? 0. Because the particle have thrown like this and reaches this. Here it will have some coordinate, but the displacement in the y-axis is 0. Displacement in the y-axis is 0. 0 it will be equal to u of y. What is the u of y? U sine of theta minus beta. What is the time? We need to calculate a time now. Okay, then minus 1 upon 2. What is the a of y? A of y is minus cos beta. Now I am putting g cos beta, and t square, t is a time. From here you can easily calculate the value of time. The t will be equal to how much? U 2u sine theta minus beta divided by g cos beta. No need to remember these formulas, only need to remember the concept, how we are calculating the thing. This is the value of flight time in this case. Okay, how to calculate a range in this case? This is a flight time. How to calculate a range? This is calculation of flight time. To calculate a range in this case. Okay, to calculate a range, we use the second equation of the horizontal motion. S is going to be ut plus half of at square. Put x over here, x over here, x over here. What is Sx? This is a range. What is the u of x? Means initial velocity along the horizontal plane, which is u cos of theta minus beta, plus half. What is the a of x? You're going to get minus, g and sine beta, t square. T square is the time that we have taken to reach from origin to this specific point A. So you need to put t value over here, you will get the range. If you want to put the value of t, you will get the range. And just I'm writing the formula directly because no need to learn this. This formula. This is the value of range in this case. Now what the third? It is asking the maximum value. Case number 3. Sorry, the option number 3. The value of theta for which the range is max. So we know this value is going to be maximum. This value is going to be maximum when sine of 2 theta minus beta will have a maximum value. Okay. What is the maximum value of this? We know. So sine theta means sine of any angle will have a value in range of -1 to +1. The maximum value of sine theta is going to be +1. So the sine of 2 theta minus beta can have a maximum value of +1. From here we can write 2 theta minus beta is going to be how much? Sine inverse 1, which is equal to 90 degree. It means the maximum value of the value of theta for which the range is going to maximum is going to be 90 minus beta divided by 2, or you can write 45 plus, sorry, the minus 1 plus 45 plus beta by 2. It means the theta, if theta is going to be 45 plus beta by 2, the range is going to be maximum in the inclined plane when we are throwing up in the inclined plane. You need to remember this formula. Till now we have discussed projectile up an inclined plane. Now we are going to discuss the case of projectile down an inclined plane. Okay, similar to the first one, don't worry, it's very easy. Projectile down an inclined plane. Okay, let's see. Let's consider here we are having a flat surface and we are having one inclined plane like this. Inclined plane like this. Okay, let's see. And the inclination angle is beta. And from point A, this is point A, we have thrown a projectile at angle theta from this angle is theta. At angle theta, I have thrown my projectile. Okay, then how to represent the initial velocity? Initial velocity will be like this, now. This is my initial velocity, u. Like this. Initial velocity, u. Okay, what will be the value of this angle? This will be same as beta, na? This is going to be beta. Find the component of u along the x-axis and y-axis. What going to be the component of u in this direction? This is going to be u cos of theta plus beta. Okay. Similarly, what will be the value of perpendicular component? It's going to be u sine of theta plus beta. Okay, to make our calculation easier, I am calculating this as a positive x direction. Okay, I am taking this as a positive x direction. The y I am going to take same. Y, this is positive and this is negative. I am taking this as a positive x direction. Okay, find the value of u of x, u of y, a of x and a of y. U of x will be same as u cos of theta plus beta. And what is the u of y? U of y, its upside is going to be positive now. U of sine theta plus beta. Now calculate a of x and a of y in this case. Let's see. This is gravity downward. It will have a two component like this and like this. Okay, this angle is going to be how much? Beta. This will be g cos beta, and this is going to be how much? This is going to be g sin beta. Now you can easily find now x-axis we have taken downward positive. It means it's going to be ax is going to be g sin of beta. And what is the ay? It is downward, minus of g cos of beta. Now put the value, you will get the result as the first case. Only thing you are going to get minus plus difference. You will get range as, I'm directly writing a formula, u cos theta capital T sec beta. You will get this formula. For the time you will get a formula like 2u sin of theta plus beta divided by 2 cos of beta. And for the range, for the maximum range, this formula is only important for R max. For the maximum value of range, you will get theta. Condition for the maximum range, you will get theta is going to be 45 minus beta by 2. Only this formula you need to remember for the inclined plane, inclined down the plane. We are throwing a projectile in downwards. You need to remember this and this only in case of inclination. Rest of the formula is not required. Only thing is to understand the concept. How to find the values of ux, uy, ax and ay. Okay, I'm going to revise this thing again. Don't worry. Here, how we have find the value. Let's see. Okay. In the first case, we have thrown a projectile like this. Okay. We are taking this as a positive x-axis and this as a y-axis. This is my y-axis. This is my x-axis. And this is the initial velocity of u. So, this I have calculated this angle. This angle I have calculated. This, how much I have got? I got theta minus beta. Now the case is simple. Find this value. Find this u of cos theta minus beta. And here you got u of sin theta minus beta. Rest of the thing is same. Only here in the inclined plane, acceleration value for the horizontal we are getting. How we have calculated the acceleration value? Like this. This is the inclined plane. Here we are getting a g. G is always going to work downward. Okay. It will have some component here and it will have a perpendicular component to this. This angle is beta. Then this is going to be g cos beta and this is going to be g sin beta. We have taken this as a x-axis. This as a x-axis. It means this is a perpendicular down. It is a y-axis component. This is a y-axis component. And this is my x-axis component. I have taken this as a positive x-axis. That's why I have taken this as a minus sign. Now it's going to be showing this direction. Okay. This is all about the projectile motion. That's about the projectile motion. In next lecture, we are going to discuss few numericals for the projectile motion.